Hello, welcome back to my channel. In today's tutorial, I'm going to show you how to design a very simple rectangular microstrip antenna for 5G communication systems using HFSS. But before we start, don't forget to subscribe to my channel so that you can get more updates on the upcoming tutorials. Also, I would like to mention that the dimensions we are going to use in these tutorials have already been calculated using the standard formulas that you can find in books or in some related works. So if you want to obtain the same results, please make sure that you use the same dimensions as the ones that we have here. So without wasting time, let's begin. As you already know, a microstrip antenna has a ground plane. So we are going to draw a box which will represent our ground plane in this case. So we are going to change the dielectric properties or the properties of the box. So double click on the box and name it ground. This is our ground. And also you can choose the properties of the ground. In this case, it has to be a conductor, so select copper. Right? You can change the color into orange or you leave it the way it is because it's not going to affect the results. So just apply and click OK. Now you can change the dimensions of the ground. Here it starts at 0 on the x-axis, 0 on the y-axis, and 0 on the z-axis. But the length of the ground plane is LS. As we can see here, the dimensions are very clear. The length of the substrate is the same as the length of the ground. That's why we are going to use 6.2 as the length of the ground plane. Alright, so LS is 6.2 millimeter. And we have the WS, which is the width of the substrate or the ground plane. It is 7.4 millimeter. Then we have the thickness of the copper, which is HP. In this case, it is 0.035, which is a standard value for as the height of the copper when you are doing your design. And click OK. Then you can see your ground plane. So the next layer is the substrate. So again, draw a box like this and try to change the dimensions, the properties of the box. This is a substrate and we can change its property into FR4. FR4 is a dielectric material which is very accessible on the market. So here you can set the transparency of the substrate at 0.4, which is 40% of transparency, and apply, then click OK. Alright, so you can change the dimensions as well. Here you can see we want our substrate to start right at the top of the ground plane. That's why we are choosing HP, the thickness of the copper. Then we have the dimensions here. Let's use LS, which we have already defined, WS, and here the height, the thickness of the substrate is, let's verify, the thickness of the substrate, as you can see here, is 1 millimeter. Alright, so we can choose 1 millimeter as the thickness of the substrate. Right, so this is our ground plane. You can see the ground and you can see the substrate right here. Then we can draw another box, in this case, which is going to represent the patch. Okay, so we can change the name. You can name it patch or rectangular patch. It is the same. And also it has to be a conductor since it needs to radiate. So select copper and change the color as well if you want it. Click OK, apply, and then OK. Then you can change the position and the dimensions of the copper of the patch. So in this case, we want our patch to start at a certain value, at a certain position in the x-axis, which is A, and here we want it to start at WS divided by 2 WP over 2 again, and here we want it to start right at the top of the substrate. That's why we are going to use HP plus HS. Alright, then we have A is 0.8. We can go back and try to verify A is 0.8. Alright, sorry. Okay, and click OK. WP is 2.5 millimeter. Let's see again. WP, yeah, 2.5 millimeter. And then we have, yeah, alright, so here we have LP, which is the length of the patch. Here we have 3.5 millimeter. Okay, you can click OK. Then we have WP, which we have already defined, and here we have the HP, which is the thickness of the copper again. Just click OK. Now you can see your patch here, your patch which you have already. You can try to change the dimensions here. We have not assigned, you can see A here is not in millimeter. That is the reason why you can see the antenna here. So what we can do, if such thing occur, you can go to HFS and design properties. Then you can see A here and click edit. Alright, now you are going to put it in millimeter. Click OK, apply. Then you can see your microstrip antenna. Right, now the next layer here is the transmission line, the feeding technique. In this case, we are using the transmission line as the feeding technique. So we are going to draw another box. Okay, alright, so we are going to change its properties again. Here, let's say the feed line, and here it is a copper because it has to radiate as well. It has to conduct. It has to be a conductor. Then we can choose the orange color again, apply. Okay, so we can change the properties as well, I mean the dimensions. Here we want it to start at A plus LP. That is the position where it has to start. Then we have here we have WS over 2 minus WF over 2, and here we have HP plus HS. Okay, then we have let's see, here we have the dimensions. WF is the width of the feed. You can look at it here, which is 0.75. okay, we have 0.75 millimeter. Click OK, and here the length of the of the feed line here is LS minus A minus LP. Okay, and then we have WF, which is the width of the feed line, and it has a copper, so the height of the copper or the thickness of the copper. Now you can see your transmission line has been designed. So you can see transmission line, the ground plane, the patch, and the substrate. Okay, so the next step is you should try to unite the two, the transmission line and the patch. To do that, you need to click on the patch and hold on the control button and click the feed line to select the two. You can see the two have been selected. So you just go to modular, and down here you can see the Boolean functions such as unite, subtract, and so on. But in this case, we need to unite the two, and just click on it. You can see they have been united. So in the next step, we need to draw a port to excite our antenna. To do that, we need to change the dimension, I mean the orientation, the plane. Instead of working on the XY plane, we can work on the YZ plane. Right? Then we draw a rectangle. Instead of using a box, you can choose a rectangle in this case. Alright, so draw a rectangle like this, which is going to represent your ports. and yeah, you can change the dimension, the properties of the rectangle. Let's say ports. Okay, don't need to change the color, or change it if you want, though it doesn't affect the final results. So here we are going to start on LS, and here on the y-axis we have WS over 2 minus WF over 2, and on the z-axis we have HP plus HS. Alright, then we have on the y-axis WF, and here we have minus HP plus HS, which is a negative dimension. Alright, so you can see this is the port, this is the excitation port. So we are going to excite this port by right clicking on the port, and down here you can see assign excitation, then you come to ports. You can see lump port here, and you select the ground as the reference and use port object name, then click OK. It has been assigned. Alright, so the next step is to assign the frequencies that we are going to use here. So we are going to unfold this object, and then go to analysis. In the analysis you can see here advanced, add solution setup, and advanced. So from here you can choose 38 gig as the theoretical resonant frequency, and you can see number of passes into 10 and click OK. Then here you see the sweep. In this case we are going to start at 30 gigahertz up to 45. Okay, 45 gigahertz. Now we are going to use fast sweep type and click OK. Alright, then we need to draw a radiation box. Alright, just right click on the workspace and choose create an open region. You leave the frequency at 38, choose radiation box and click OK. You can see now this is your final design. Alright, so alright, you can see you have completed your design, so you can come to simulation and validate to see whether all everything is okay. You can see here there is no design error, so just close this window and try to analyze. But before that you need to save your project. Here just click on save. I'm gonna save it on the desktop and choose let's say tutorial 1. It's gonna remain alright. So after you've saved your design, just click on analyze all to see the result that you've obtained. So it's going to take some time before it completes. Right, so you can see the progress here for your design. So let's give it time to finish. Alright, now you can see the simulation has been completed. You can see here the message. We have normal completion of the simulation on the server. So just close this window. Then you can try to plot the result here. We are going to start by the S11 parameter, which is the reflection coefficient. Just new report. Then you can see, you can try to analyze the bandwidth that you have obtained by considering the minus 10 dB reflection coefficient criteria. And also you can find the resonant frequency here. You can add a marker as like this. So our antenna resonates at 39.875 gigahertz. So this is an antenna that can operate for 5G communication systems. So another thing you can do, you can also plot the VSWR, which tells you how much power is being reflected from the antenna to the back to the transmission line. So you can do a new report like this. You can see here it is below 2 in the frequency band. So thank you guys for watching these tutorials. See you next time.